MCP just killed sessions. That sounds like the entire protocol became stateless. It did not, and that distinction is what developers need to understand. On July 28, 2026, MCP released a new protocol revision. The headline change is a stateless protocol core. In the older model, a client began with an initialize request. The client and server negotiated the protocol version and capabilities, and the server could create a protocol session. Later requests could carry an Mcp-Session-Id and depend on information established earlier. That created operational baggage, sticky routing, shared session storage, expiration, and cleanup. If a server instance disappeared, the protocol context attached to it could disappear too. The new specification removes that lifecycle. There is no initialize request, no initialize notification, and no Mcp-Session-Id header. Instead, every request carries its protocol version and client capabilities. A client that wants to inspect a server first can call the server discover method. Servers must implement discovery, but clients do not have to call it. Now, any self-contained request can land on any healthy server replica behind a normal round-robin load balancer. No sticky routing for protocol negotiation, no shared protocol session store. If one instance dies between calls, another can handle the next request. But state did not disappear. A shopping cart still has items. Browser automation still needs a browser context. Database transactions, files, and long-running jobs still need durable state. The difference is that this state must be explicit. A tool can return a basket ID, browser ID, transaction ID, or task ID. The client passes that handle into the next tool call. State moves out of a hidden transport session and into ordinary application data. That does not make every server storage free. A handle may still point to a database or shared service. What disappeared is the mandatory protocol session store, not application storage. And a handle is not authorization. Handles can appear in model context or logs. The server must authenticate every request and verify that the current user may access the state behind that handle. The specification also changes interactive workflows. Older MCP versions allowed the server to send requests back to the client. That required a bidirectional connection. The replacement is called multi-round-trip requests. When a tool needs confirmation or missing information, the server returns an input required result. The client gathers the answer, then retries the original method with the response attached and a new request ID. This preserves confirmations and user input without keeping hidden session state between calls. The server may also return an opaque request state. Because that value comes back through the client, it must be protected against tampering if it affects authorization, resources, or business logic. So, is all of MCP stateless now? No. A request can still return a server-sent event stream. Long-lived change notifications can use a subscription listen stream. Tasks are deliberately durable and stateful. Authentication records, databases, files, and application workflows remain stateful. The core request and response model is stateless. The entire system is not. There is also a reliability trade-off. Stream resumability and event redelivery are gone. If an in-flight response stream breaks, the request is lost. The client must issue a new request with a new ID. MCP does not provide an exactly once guarantee. Retrying a tool that changes data can repeat the side effect. Mutation tools should use idempotency keys or deduplication. Work that must survive disconnects belongs in the tasks extension. The same release also makes Streamable HTTP easier to operate. Protocol versions, methods, and named operations appear in headers, allowing gateways to route and authorize without parsing the full JSON body. List responses include cache hints, reducing repeated catalog requests. For migration, remember that older MCP revisions still use sessions. Modern-only and legacy-only implementations do not automatically understand each other. The official TypeScript, Python, Go, and C# SDKs support the new revision, but production systems should support both protocol eras during rollout. Remove dependencies on session IDs. Authenticate every request. Pass application state through explicit handles. Authorize those handles independently. Handle input required responses, and make every retry safe. The one-line summary is this. MCP did not eliminate state. It eliminated hidden protocol sessions. That makes MCP easier to scale, easier to recover, and cleaner to operate, without pretending that state, storage, authorization, or retry risks have vanished.